Good evening, everyone. I am your host and instructor, Laney Shaughnessy, and welcome to Spindle TV, your best source for CNC CAD/CAM training videos. Spindle TV is brought to you by Digital Woodcarver, inspiring your creativity and providing you with the tools to create your own unique masterpieces. Hello. Welcome, everybody. All right, tonight is Tuesday night. It is not Monday night. We did not have a class last night. Mr. Burl Tishner and myself were doing some work trying to make things better for Digital Woodcarver customers and future customers alike. So we worked late into the evening and everything, and we did not get done in time for me to have class last night, so we had to postpone for this evening. So I'm sorry about that, to throw your schedules in the throw them around in the loop and all that stuff. But next week we'll be back to Monday night. This week we just got tied up. It's we're going into our summer show seasons and specials and things like that, and I'm working on filming a new commercial. A couple new commercials for Digital Woodcarver and everything, so we're just a lot of stuff going on. I hope you all are doing well, and I hope that my audio is loud and clear and all that wonderful stuff. Hopefully it is. Let me know if it is. Give me a little thumbs up and things. All that wonderful stuff. I didn't realize that there was like a little emoji thing down here. That's pretty cool. All right. So, neato stuff in the chat area. So I want to welcome everybody and thank you for joining me. Thank you for joining me. Now, a couple of weeks back, we had Back to Basics. We did a Back to Basics course, and we went over things like the job setup, and we went over a couple of different smaller items just to kind of get the basics of the Vectric software down. And this is Back to Basics 2. So what we're going to be doing is we're going to look at some basic processes, working through some things such as gadgets. We're going to take a look at gadgets, and especially the keyhole gadget. I had someone ask if I could specifically kind of give a mention to that and a little show how. And I'm going to show you how to create a keyhole toolpath with the gadget and without the gadget if you don't have a gadget. I don't know if we got into it last time. I'd actually have to go back and refresh my memory, but we're going to look at our tool database a little bit and adding a form tool. I think I might have covered that a little bit in the last Back to Basics course, but we're going to touch on that again. We're going to add a regular bit, then we're going to add a form tool, like a round over bit, just to kind of show that process, because once you do one, it's the same, rinse and repeat. The only thing that's different is the actual form of the bit that you're drawing in when you are doing the form bit. And we're going to talk a little bit more about that, but we're going to go over some of the other basics, and we're actually going to create a design this time and stuff to make the workflow a little bit easier, a little bit more enjoyable, and that you can get something out of it. So it's just not just jumping all over the software going, look at this and look at that and all that things. We're going to actually make a project, and we're going to talk through this stuff. And so we'll give everybody a chance. It's 7:13 on my end of the spectrum. We're going to give everybody a chance to pop on in and stuff. It's most likely going to be a very light class night as far as attendance, because everybody's used to attending on Monday and not many people will pop in. But I want to thank each and every one of you that jumped in with me tonight. So we'll take a big old sip of this Dr. Pepper and we'll get moving along. All right, and I got to keep remembering, you're here. I got to look at my camera here. All that wonderful stuff. Alrighty. So, well, welcome, Sylvia. Good to see you. And Roger and Reginald and Kevin and everyone. I appreciate your time. for popping in and stuff. And I got to figure out where that thumbs up is coming from. On my emojis, all I see is happy faces and sad faces and faces. I don't see the thumbs up thing. I have to figure out how to do a thumbs up in the top chat. All right, so here we go. We'll give it a couple more minutes and everything. Now, want this to be interactive. So if you have any questions about your Vectric software. I don't care what the version is, desktop, pro, or Aspire. If you have any questions, be sure to ask those questions and stuff, and we'll interact. We are going to be doing a Q&A at the end. But if you have a question, hey Jeff, good to see you. If you have a question that is relative or kind of involves the area that we happen to be working in and stuff, go ahead and ask. That's the only way you learn things, especially with these live events and live classes and all. Is you're here to learn, and I might not be hitting on a particular topic or something, or I might overlook a certain thing that you're like, oh, I wish he would have shown that. Well, throw it out there, and we'll see if we can fit it in. On the basics, let's if it's an advanced thing, still ask the question, but I may reserve that to the end when we're doing the Q&A. No. Do you have to? Okay, that's a simple enough question. Do you have to own a digital woodcarver to get one of these hats? No, actually, the digital woodcarver hats, they're not free, unfortunately. They are for sale. They're only a couple of bucks, but they're on the digitalwoodcarver.com website under the shop page. I believe we have an apparel area and everything where you can get one of these fancy-dancy little hats. This hat has been run through the ringer. This is my goodness, I need a haircut hat. Whenever I am in desperate need of a haircut, and a shave or something or whatever. I don't know what a shave has to do with wearing a hat, but I throw on the hat until I can get over and get her cut. But good question, Todd. But yeah, no, we have hats in stock. Go on in. Bro will be like, man, what are we getting all these orders for hats for all of a sudden? All right, so it's 7:16. Let's get this show on the road. Let's go ahead and switch over to our shot here. Let's see here. That would be our VCard Pro scene. Bam. All right. So now I have a fancy dancy new Streamlabs remote tied into my phone here. Let me open that up so I can maneuver and things a little bit better. Dum da da dum. Streamlabs remote. Okay. Now, I said this is going to kind of be a bit project based, and so we're going to create a project as we go along. And welcome to all you folks that are popping in on us now. So let's kind of let's go back to square one here, and because I want to talk about the keyhole and things like that, we're actually gonna lay out kind of a two-sided project, and in this fashion and stuff, in this sign and all, and we're going to take a look at that. So in this job setup, we're going to do a double-sided job. Two-sided job, and on the x-axis, which is represented by the width of your screen, left to right, we're going to do a project that is 19 inches in length with a width of 11 1/4 and a thickness of 3/4 of an inch. Okay. Now, I work off for me, my job setup, I work off of my spoil board is my Z0 position. So for me, my Z0 position setup would normally be my machine bed. And depending on your setup, you're either going to be working off your material surface, meaning you're touching off on the material surface, off the top side. Then when you flip the board over, you would zero off on that top side again. The new top side, let's call it side 2. We got side 1 and side 2. You'd be referencing off both of those sides. You could actually reference off of the original side, side 1. You'd be touching off on the top, and then when you flip the board over, you'd be touching off on your wasteboard or your tabletop for side 2. So you could do that if you wanted to zero out off of the same side. For me, I work off of the machine bed. Unless the only time that I would zero off the same side would be that if I have a board that it's crucial that my model or something is dead center, and it's dead center. I want to make sure that, if there is any little differences in the thickness of my material, that I'm not off one or the other. So I would reference off of the side of each side, alternatively. But I'm going to set this up as the machine bed, just something that I'm normally used to doing. And then the XY datum position, we can start from any of the 4 corners or from the center. Because of my jig and my wasteboard and stuff, I'm going to start from the bottom left corner for my Z0 position, or not my Z0 position, we just went through that. My XY datum position. And now I've got to tell the software, which way am I flipping my board? Am I flipping my board along my X-axis, or am I flipping the board along my Y-axis, or vice versa if you have a machine whose X and Y is different. And so for me, I'm going to be flipping my board along my Y-axis. And so that will be the second option here. So let's go ahead and click OK. And that will set us up. Yeah, Mike, we're going to have a little bit of buffering. We always have from time to time. There's going to be a slight bit of buffering. I'm going to try my best to keep it to a minimum. But until I find a better controller, and also maybe I'm thinking about buying a new GPU and a new gaming processor, or to see if I can pump up my computer a little bit and see if that might help. I've been reading where that may help, it may not, but who knows. We're going to try our best to keep the buffering down to a minimum. Okay, so now one of the things that you'll notice with the two-sided setup, and now this, the two-sided job is new. It's version 9 and 9.5. Version 9 actually is when it came out, 9.0 and all. But we have the ability now to work with two sides of the material. And when we choose that double-sided job setup, we have some new icons at the top of our screen. We have an icon that is for flipping our material. And notice my rulers here when I'm on the top side. You will see this little icon in the top left with a black arrow pointing to the top side of the board. And if I were to flip that position, now you'll see that black arrow is pointing to the bottom side of the board, which is, bottom side 2. And you'll notice that the rulers have changed colors. This is letting me know visually, letting me know that I'm in the bottom side of the material. So this little icon here is how we toggle between the top and the bottom. Now, this icon here, it doesn't do anything for us. It just shows us our flip direction. So I'm flipping along the Y and everything. And that flip direction is important because when I'm bringing or putting things onto that second side, that bottom side, it's going to position them, especially if they're vectors that are on the front side as well. When it mirrors those and flips them to the bottom side, it's going to mirror and flip them accordingly so that they are in the correct position when we actually at our physical machines flip our board and carve and stuff. So that's going to show us our little indicator there. Now, for this project, I'm just going to lay out a very simple type of sign and project and everything. And to go with basics, I want to talk a little bit about image tracing and stuff like that. And now we covered image tracing a little bit in basics, version 1. Back to Basics 1, I believe, if I'm not mistaken, we did. But we're going to be kind of repeating a little bit because I need to trace an image to bring it into the software and stuff. And so first thing I'm going to do is I'm going to import a vector and everything. And so I'm going to go into my downloads. I believe it's in downloads. I'm looking for my trout. It's not in downloads, Laney. It is under my desktop. Now, of course, I have everything here, and I'm like, I got it. It's under my pictures. Why am I not? Well, you son of a gun. We're going to start off on the right foot today. Let's see here. Where is my trout? They're like, trout? What the heck is a trout? That's a fish. I think you all know that. All right, let's see here. Desktop. It shouldn't be under class files. Man, I just had it. I looked at that thing 100 times saying, oh, there it is. That's what I need for Monday's class. And of course, Laney. That's a model. That's not it. Oh, Laney, you son of a gun. Let's go down to my backup drive here. And the trout would start with T. Isn't that just the damnedest thing? All right. This is what you call organization at its finest, ladies and gentlemen. Let's see here. DXF. That's my DXF files. There it is. I knew... Nope, that's the damn bass. I saw a fish's tail. I got excited there for a minute. Let's see here. Streamlabs. There's the tulips. Okay, so we're in the right area. All right. That's all right. We'll work with the tulips. I'll find the trout here in a minute. Don't know what the trout and tulips have to do with each other, but we're tracing an image here, folks. All right, so we'll work with the tulips for now. So the first thing I'm going to do is I'm going to go into my trace bitmap tool, and I'm going to turn off my bitmap fading, and let's get this image about where I want it, 76%. I'm going to turn up my noise filter, kind of filter out any miscellaneous noise, and let's click apply and close. So my corner fit, I'm working with the default corner fit. The Vectric's default corner fit is phenomenal. It's pretty much smack dab on where I need it. The noise filter, if I'm working with a low resolution image, I'm going to use that noise filter to create my tracing and everything. But where the image is a higher quality, then you may not need that noise filter up very much from there and all, because the noise, anything 10 pixels or less, when you're working with a pixelated image, all of those pixels and everything, there's a number value to them, and I have no idea what that number value is or how they determine what a 1 pixel is, what a 10 pixels or less and things. But if an object or a shape falls under that noise filter level that I have it set at, then it's not going to trace it, it's going to ignore it. And so I usually work between 6 and 8 on my noise filter and stuff and everything. And so the all that wonderful stuff. Now, What I'd like to do with this is this image here, kind of changing it up a little bit from the bass, but it still falls in the same category. I'd actually like to do an inlay, and I'm going to be doing what's considered a V-carve inlay in all. So you're going to learn a little bit about V-carve inlays tonight, and I was going to do it with the trout, but the tulips is just as fine. I'm going to add some text and stuff over on the left. It might be, something for the special someone in my life that I want to have hang on the wall for her. And I don't have anyone special in the life, but you never know. We'll give it to somebody. But for this, I have two choices. If I want to do an inlay, I can do a traditional inlay where I'm using a round end mill, most likely a very small diameter end mill, because when we are working with an inlay, we have to consider the radius of that bit of that end mill. And if we have a design that has sharp corners or detail, then we're going to lose that detail if we did our traditional inlay using the regular inlay toolpath here. When we're creating a toolpath, because we're going to be using an end mill, a round bit that we're all those sharp corners it can't get to create those nice points and things. So I have to just be mindful of that whatever design I'm doing, if I am going to use the traditional inlay, then I have to just know that I may lose some of that corner detail, inside and outside corner detail. But I'm not doing a traditional inlay. I'm actually going to do a V-carve inlay toolpath. And a V-carve inlay toolpath lets me use a V-bit. Whether that V-bit is a 60-degree V-bit, 22-degree V-bit, 90-degree V-bit, as long as I use the same V-bit for both the male cut and the female cut. Okay, so and we're going to talk about the V-carve inlay, and we're going to talk about how that inlay is created and what's the best. Now you'll see online, if you ever looked at any of the Vectric tutorials on V-carve inlays, or if you looked online, if that was something you wanted to try out and you went and researched it or Googled it or YouTubed it and stuff, you would see that a lot of people are pretty much using the same parameters. And that's the thing about a V-carve inlay, your settings will not vary. When I say settings, I'm talking about the actual toolpath that we use, and your toolpath for your female cut and your toolpath for your male cut. They're going to pretty much be the same, or they're going to fall pretty darn close to in the same line of things, and they won't vary. The only thing that's going to change is your design. And so with me, what you're going to see here is you're going to see something that's not that you if you went and YouTubed it and stuff, I'll show you what their normal settings and things are, and then I'll show you the settings that I use, and then I'll explain the difference on why we would maybe vary a little bit and stuff. So you're going to see that a little bit. So we're going to be doing a V-carve inlay for this. Before we get into the toolpaths and everything, I don't want to jump into the toolpaths just yet. I want to go ahead and lay out my design and stuff and everything. And so we're going to add some text in here. So let's go ahead and open up our text box, and here's where the basics class comes in. We're going to talk about, Lainey, why do we have two separate ways of writing text? We have our draw text tool within the software. We also have our draw text tool within a vector box. Now, our draw text tool, as we open it up, especially in 9 and 9.5 now, you will notice something when we open the software, that there's no apply button. But a box pops up on the screen, and this box in relative size and everything is related to the text height. If that text height were to change, so does that box height and everything. And also, where that box is located is in direct relation to where that text is going to show up on the screen. So we can click,
We can place that box in various places, and we can also, drag that box around, with our mouse and stuff and everything. But we just want to position it in a way that we can get it in the general area that we want to work with. And then after that, after we create our text and whatever, we'll lay it out. So in this case, if I, let's see here. Let's I'm trying to be sentimental. Let's do something cutesy here. All right. So we'll do something very simple. Okay. Oh God. I'm gonna lose some of my man cards on this one. All right. Love is the flower you've got to let grow. Aw, isn't that nice? All right, so don't make fun of me. All right, so here we go. Let's go with our let's go with a 1 1/4 inch high text. And notice I'm in center, so all my text is kind of centered on each other. I'm going to go with a left justification because even though I'm writing this as one whole text block, I'm going to be moving the text around. I'm going to change the word love. I'm going to change the font and stuff and the size and all. And we're going to be breaking this text block up into individual text lines. But I can write all of the text out and then I can come in and change it about and everything. So let's go ahead and let's go with that 1 1/4, and we'll go ahead and click close. Now I'm going to take my little flowers over here and let's kind of move them into position. Let's get them right about here. Now my text block, this is the draw text. So I can, when I'm using the draw text block, I can choose my fonts. I can choose my text height. I can choose the different types of things. Where it's positioned, left, right, or center, justified, and all of that wonderful stuff. And so, in this, I'm going to end up changing it about. But when I've created this, just like I said, I created it in a text block. So now what happens if I want to select on this text to maybe move the word love around or is the flower or what have you? Well, when I click on it, everything is selected. So I need to right click and I need to do what's called breaking. I need to break the text block into individual text lines, meaning that it's still going to be text. I'm not altering it in any way, but what I'm doing is I'm breaking the block into individual lines so I can work with them one at a time. And then I could come over here and I can change a little bit of my positioning and stuff. We're going to talk about duplicate vectors and all that stuff in a moment because I can see I have a couple and I want you to be able to identify when you have a couple as well. So let's get this thrown up in here. On this here, I'm going to kind of throw this a little bit bigger. And now on the word love, like I said, I'm losing my man card with all this sentimental love talk tonight, but I'm going to go back into my text box, my draw text block, and I'm going to change the font up a little bit, maybe give it something a little bit more stylish. And here's the thing, especially if you're new. Now, you may have seen me use this before, but for those of you that might be new to the Vectric software and like, man, I really wish there was an easy way to select and choose fonts, we're going to use WordMarket. WordMarket is one of my favorite websites to use to help me choose fonts and everything. And if you don't have it bookmarked in your browser, definitely use it. It's wordmark.it, and so you can see all of your fonts and everything not workmark, Word, WORDMARK.IT. Word, Laney, Word Market. Now, when you're on the Word Market page, you'll see a little option for the Adobe Flash Player. Allow the Flash Player so that it shows you all of your fonts, because some of your fonts that aren't really true type fonts and everything, some of your fonts, it won't show unless that Adobe Flash Player is on. So I'm going to type in the word love. Lord have mercy, Laney. All right, and I'm going to hit enter. And now this gives me the opportunity to look at, some of my fonts and things, and be able to choose the font that I want to use. And, a new favorite font of mine is the cast iron font. I really kind of like that. Defont.com. If you're ever playing around, the cast iron, it's called. It's a pretty cool font. It's got a really cool look to it. And I don't know if that fits unless this, unless we can kind of make it almost look like vines and weeds are growing up around the letters and stuff. I don't think it quite fits the theme for tonight's little love sign, but just wanted to throw that out there because it is a pretty cool font. I like it a lot. And I believe the font that I'm going to be using tonight is my marketing script font. And I think I'm going to actually give it a little bit of a drop shadow. Maybe so or maybe not. But I think I'm going to go with a little bit of a script font tonight. So marketing script has just won the day. Marketing script has just won the day. All right, so it's a really cool site, wordmark.it. Give it a shot, not a shout. Give it a shot sometime and give it a try. So on my marketing script font, I have 3 different styles, and one of them is called a shadow. And it creates kind of a drop shadow effect and everything. And that's the one I'm actually going to go with, And you'll see when it V-carves, it's got a pretty cool look to it. David Kinsey, thank you for pointing that out. I forgot that I was on a different scene where it does not show the web browser. So let me take a second here and give me a moment. Let me add a web shot scene to my class because we're going to be using that again in a moment. And let me add a source to that. And that source is going to be a window capture. So we'll add that. All right, give me just 1 second. Oh, let's see here. Display. All right, screen capture. Did I already have that? Intro splash. No, okay. Thought I had it already and was like, wait a minute. Add source, use an existing source. All right, let me add one more thing to this so you can see it, because right now you're not seeing it. Let's go into okie dokie. All right, give it a second. Give it a second. Stand by. All right, so you should be at some point in time, you should start hearing my voice again and everything. Give me a thumbs up if you can, when you can hear me. I won't say too much until I get a thumbs up from somebody. But in your web browser, we're going to type in wordmark, WORDMARK .it, wordmarket. Now with wordmarket, this is a place that helps you pick out fonts. It shows you the fonts that are installed on your computer. And one of the things that you would want to do is it'll ask you to enable Adobe Flash. And with the Adobe Flash, it shows you all of your fonts, all your TrueType fonts, SubType fonts. It shows you all the fonts that you have installed. And so when we type in a word or a phrase and things and we hit enter, we now have the ability to choose. We now have the ability to choose a font. Based on, we can see it visibly. We're not, we've got much, it's kind of a real time example of what it would look like. And then the font names are listed underneath the actual preview of the word and things. And so what you weren't seeing a moment ago, but what you were hearing was me highly recommending the cast iron font. From defont.com, the cast iron font. I thought it was a pretty cool looking font and stuff, and I said that might not fit our theme tonight, but unless we can make this little lower area kind of almost make them think that it's kind of vines growing up on the letters or what have you. So that was the cast iron font that you see over here and to the left of your screen. All right. But what we ended up choosing is, ended up using or going with my marketing script font, kind of a scripty type font. And with the marketing script font, there are 3 different styles that when you download that font, there are 3 different styles that you can choose. And I'm going to be using the one that has this little drop shadow because it's a nice effect when it's actually V-carved and everything. There's a nice little outline of the letter that's carved, but then it has this kind of dark area that gets carved down and carved away. And if I were painting this in a sense, so let's say if I was giving it some color, and everything, it would look just like that sample or example with that kind of drop down. It kind of gives it kind of a shadow look. Kind of like it. So I think that's what we're going to go with for the word love. All right. Now, let's get back to our pro screen here. And you're going to see that I've already chosen the marketing script with the drop shadow. And looking at this font, basically, you can imagine how it's going to carve because remember, a V-carve toolpath carves between the lines. So it's going to carve between these outer lines here around the design. It's going to skip the letter and then it's going to carve, these other areas here and things. So it's going to kind of give this nice little outline around the letters. It looks really good and stuff. So I think that's what we're going to go with the word love. And so let's get that into kind of position. And let's see here. Now, on this one, I want to be a little bit creative and stuff. So I'm going to, on You've Got to Let It Grow, I want to think outside the box. I'm going to do a little bit of a distortion. And I'm going to distort with inside of a bounding box here on this text and all. And now once I do this, I got to commit to this font. I've got to commit to the font. I've got to commit to the letters and all because the spacing and if there was a curvature, whatever. Well, not necessarily a curvature because we're going to be distorting, but because once I do this, it's like sticking we're creating an envelope, what's called an envelope. It's like sticking these letters inside of a paper envelope, and however I bend and distort that envelope, those letters are going to bend and distort as well. But they're no longer a font. I can't go back and change the font. I can't change the spelling. If I messed up the spelling, I would have to end up deleting it and redoing it. So I've got I'm committed to this font and everything. So I'm going to go ahead and click apply to distort this. And now what that does is it puts a vector envelope around my letters and all. And now as I change or manipulate that envelope, the words and everything will change along with it and stuff. And what I'd like to do here is this line, this dotted line that you see here, I can add points in different places, nodes and stuff and all. And so I'm going to turn this point from a line, from a line into a curve, a Bezier curve. And what I'd like to do is I'm just going to kind of bring this down a little bit, and I'm going to give this just a little bit of curvature. Okay. And I'd like to insert right about the G. Right about the G, I'd like to insert a point there. And I'd like to turn this into a line and pull this up just a little bit even. Now this is like nodes and stuff. If I were to select this point over here and then also hold down my shift key and select this point, my up and down on my screen is my Y. It is my Y axis. And so if I hit the letter Y on the keyboard, it will pull those two, it will raise that second node that I just selected second. It'll level it out, raise it up, because on the Y, up and down, it'll raise it up and level it out with that first node I have selected. And what I want this to do is I want, because of the words you've got to let it grow, I want to give the impression that the letters are growing. Right. We're going to think outside the box a little bit there. And everything. So you got to let it grow. Aw, isn't that cute? Okay, so I just wanted to do a slight little bit of distortion in there and everything. All right, so this is my sign. Now remember, the tulips I want to do an inlay with. It's going to be a V-carve inlay. On the rest of the design, it's going to be just a V-carve text. I'm going to use my V-bit to cut it, and since I'm going to be using my 60 or my 90, depending on which bit I choose to decide to use for the V-carve part of it, I'm going to most likely keep that bit in while I'm doing the text cutout and stuff as well too. Now let's talk about that a minute. Let's make sure that we understand how a V-carve toolpath works and what the different size V-bits do for us. No matter what, a V-carve toolpath will cut between the lines. And so to deviate from this a little bit, I'm going to draw a small rectangle here. And let's assume that we were going to V-carve this rectangle. Now the V-bit is going to remove all of this area and it's going to look at the space between these lines. Usually on the Y it looks at that, but it'll vary. But it's going to look at the space between these lines, and it's automatically going to calculate how deep it needs to cut for those lines to meet at a V. So if I'm using a 22-degree V-bit, a 60-degree V-bit, or a 90-degree V-bit, it's going to, the depth of cut is going to vary based on the angle of that cut. Now, if I came in and I created another set of lines on the outside of this rectangle, let's say we offset this outward 1/8 of an inch and everything, and I selected this whole design to V-carve. Well, now what it's doing is it's carving between these two lines, the two outer lines, and it's working its way in. So it's going to carve, around these, between these two lines here, and it's going to leave that center area untouched. It's going to be kind of raised up, and I'm going to have this rectangular kind of groove, you know, around, you know. But if I added something inside of this rectangle, let's say that I added the word let's go with a 0.5 here, and I throw the word home in here. Well, now I'm V-carving. It's going to V-carve around the border between these two lines. It's going to skip between these two lines, and now it's going to carve my word home out. You know, so let's look at that in an actual scenario. So let's go over to our V-carve toolpath, and first things first, I'm just gonna I'll create a V-carve toolpath on the actual rectangle by itself. So we'll calculate that toolpath. I'm using a 60-degree V-bit, and you know, what we can expect from this is that I'm going to have a rectangular V-cut, and it's going to be cut to, and let's turn the color off, it's going to be cut to a depth that the two lines were to meet at a V at that 60-degree angle. Okay, so if I were to tilt this a little bit, and let's change this to a maple to kind of give a little bit of a better view. But we would see that we have this V cut, you know, down to an angle. All right, so let's go ahead and open up that tool path again, and let's add in the second border and calculate it now. Now when I calculate this and I preview this cut, now we end up with a just basically kind of a V-carve groove around, and let's turn the color off, and back to a maple. All right, and so now I have kind of this V groove around my rectangle. And so in the third version, if we open that toolpath back up and I add the word home into the mix, now I have everything selected. Well, now I'm going to have the word home V-carved with that border and everything around it. Well, if I wanted it the opposite way, if I wanted it done the opposite way, where I have all of the material carved around the letters away and then the word home raised, because I'm trying to get that kind of effect and everything, I would either have to deselect the outermost line or add another outer line. So in my case, I don't want to deselect. I would like to have that kind of rim around or what have you. So I'm going to add another line. So I'll take my outer line here and I will just offset this out, you know, another 1/8 of an inch, what have you. And now I'm going to select all of this, and now looking at this, it's going to be carving between these two lines. It's going to skip between these two. It's going to carve between these two, meaning it's carving all of this around here, and it's going to skip between the letters. So it's carving, you know, between the lines, but it skips every other set. So if I were to come in here and to add this new line into the mix, and I calculate this out, if I reset this preview back to a blank board, and I come in here and let me change this. I wish this would stay defaulted when one chooses it. But if I were to preview this toolpath, now I'm going to have the outside border. Then the inside of my, you know, around my letters is going to be carved, and it's going to be carved to the depth that it automatically calculates based on the space or the width of those lines. And I wouldn't, if I were doing this, I would not want it to look like that. I would not want it to be so deep on the left and the right of the word home. That's where we have the option of choosing a flat depth. Now, the flat depth in a V-carve toolpath does not mean that every bit of my design is going to be carved to 1/8 of an inch or whatever depth that I specify. Okay, what it means is if there's any part of my design that would have exceeded my flat depth, then it gets limited and it gets flattened off at that depth. But if any other part of my design wasn't going to come to that, that depth that I've specified, then it just cuts to its normal V-cut shape. So I'm going to set this to a, if I look here, and by the way, when you're in the 3D view, if you move your mouse over your preview and everything, and if you look at the bottom right corner, it will tell you the depth of cut. So my depth of cut, if I got the mouse right on the point of that center, is running roughly around 0.21, a little under a quarter of an inch and everything, 0.3, so a little over a quarter of an inch. So if I were to limit my cut, let's say I wanted my cut to be limited or flat depth at 0.1875, 3/8 of an inch, and I calculated that toolpath, well, any part of my design that would have exceeded, in its natural state, would have exceeded that 3/16 of an inch, that 0.1875, it's going to get limited to that. So if I were to reset that preview, and I were to preview that toolpath, it's going to get limited and flattened out in those areas to the depth that I specify and everything. But we're getting that raised effect, and in this case I would use 1/8 of an inch as the flat depth. For me, it looks much better than the deeper cuts, and everything. I just don't like the deeper cuts on that. If I came back in here and limited that to 0.125, calculated that out, especially on a design this small, and reset that back, preview that cut, it'd be 1/8 of an inch. Now we're seeing tool marks and everything on the left and the right of the text and all, because I didn't set a flat depth. When I set the flat depth, I did not choose to use a flat area clearance tool, which is another tool, another end mill that I could use to work on just the flat areas and stuff. But that's, that V-carve toolpath, because it carves every other, set of lines between the lines and stuff. We have to be mindful of that when we're doing a design. If we're like, man, I don't want it to carve that middle away. How do I stop it from carving that middle away? I just want it to carve this area away and everything. We may have to create an offset of that area. We may have to add an additional line or, perimeter or what have you in that particular part of that design, so it doesn't carve that area, so it leaves it untouched or whatever the case may be. There's a lot of different scenarios where, this will come about. And a lot of the calls that I get are reverting them out. Laney, I can't, it's wanting to carve this away, all of this away, and I just wanted to carve that away. And when I'm doing this and all, and it's just a matter of adding that additional perimeter and things. And so Stephen Rice asked the question, can you use a straight-sided bit in a V-carve? Well, in the V-carve toolpath, when we select the tool, the main tool, notice that the end mills from our tool database and everything are we're not able to select them and everything. This is typically designed for possibly a tapered ball nose or a V-bit and things like that. So we can choose one of those type of bits, and I'm choosing a V-bit for this. But when I have a flat depth, I can use that flat depth, see how it's not chosen here, use a flat depth area, is kind of grayed out. It doesn't let me choose it when I have no flat depth. But when I use a flat depth, I now have the option to use that flat area clearance tool. And so if I were to choose that, now I can select that flat tool. And notice now when I hit select on the flat area clearance tool, notice that all my V bits and my ball nose bits and everything are grayed out. My tapered ball nose is anything that has that angle and everything. They're grayed out. They won't let me select them. But my end mills or my straight ball noses, I can use. My straight bits and stuff. So I would choose an appropriate sized end mill, for the design, and that would fit in that area and all. And now when I calculate this toolpath, it's going to give me two separate files. Two separate toolpaths. I've got a VCarve 1 pocket. By default, the name is VCarve 1. But I have one that says pocket next to it. That's the end mill. That's that flat area clearance tool. And then my other toolpath that it created was the VCarve toolpath, which is the V-bit that I'm going to be using in this scenario. So if I were to now preview this cut and everything, now my flat region areas and everything are much cleaner. Let's turn off the color and let's go back to kind of a maple. Now you can see there are no tool marks and everything in that area because my end mill, which I use a 16th inch end mill, was able to get in there and flatten those areas out to give me that, you know, kind of raised effect. And you know, now if I turned around and I opened this toolpath back up, and if I were to deselect one of my lines, and I'll just do the outer line, now I'm completely changing it up. Now I'm carving between these two lines, leaving this area uncarved, and then carving between these two lines. So it's kind of skipping every other set. So if I were to calculate this now, it's saying that although the carving tool can reach the flat bottom depth, there's not enough space to be created. So my 16th inch end mill is not going to get used in this because there's not enough room for it to fit. It doesn't fit. So it's just that message was telling me, hey, we're not going to use the end mill, the flat depth, because it can't fit in that area. You know, my letters are too small and stuff. So if I were to preview the toolpath and everything, I'm still going to get my flat depth and all, but notice that my design isn't flattened out. It's running to the straight V cut that it did because none of the cuts were going to exceed that 1/8 of an inch. Okay, so a flat depth means, hey, it's going to limit the cut so nothing can go past that. It's going to flatten everything out that's going to normally go past that to 1/8 of an inch or whatever depth you specify. And then when you choose a flat area clearance tool, you have, when you choose to use a flat depth, should I say, you then have the opportunity to use a flat area clearance tool. All right, so I just wanted to explain that process to you and all. And so that way you understand when I'm talking about the way that the word love is going to carve, it's going to be carving between these two outer lines, leaving this center area raised up and stuff, and it's going to kind of give the letters that outline look and everything, which I really like. And all, and I wanted, the reason why I went into that whole spiel about the V-carve toolpath and all that is so you understood what I was talking about when I was talking about how the word love is actually going to look when it's carved, when it's V-carved. It actually has a really nice look to it and everything. All right, so we've got our design here. Now, when we are doing an inlay, okay, when we're doing an inlay, the traditional inlay using the inlay toolpath, we don't have to mirror this object, you know, that I would be inlaying. I would just create, I would select the vectors and I would choose if this is going to be my male part of my inlay or my female part of my inlay, and I would create that appropriately and all. And of course, this would be the pocket. This would be the female part of the inlay. And then out of a contrasting piece of material or materials, I would create my male cuts because, you know, hey, I might want to, instead of just, you know, walnut on maple or something, I might want to be a little creative and use a little rosewood for the tulips to kind of give them a kind of a red look to them. I might want to use a little bit of I don't know, orange asage or something, you know, to give those flowers maybe an orange look or something and all. I might want to use a little bit of aspen or you know, like a soft or a hard maple, something that has a nice little white, yellowish white tone to it for the leaves or the stems and things like that. I may want to kind of, you know, dress this up. Now, I'm not going to do that. I'm not going to do that. I'm just going to use, you know, a contrasting color from my, you know, what my board color is going to be. I'm not going to do the multiple colors, but if I were, then I would, you know, I would do it with the, you know, the traditional inlay, so I could cut those individual pieces out and stuff. What we're going to be doing is a V-carve inlay, meaning that we're going to be using our V-carve toolpath to cut out this, this design and everything. And so let me grab a set of vectors, And this set of vectors is courtesy of Becky over at Vectric. So let me import a set of vectors. Where's my resources? Give me a second. They're in here somewhere. There's my Plex documents. Where's my folder at? Where's my folder? That'll work. Give me a moment, folks. Have a little patience with me. All right, Miss Becky, where did I put those files? Jeez Louise. All right, let me grab my flash drive. I know they're on my flash drive, so hang tight with me for 1 second while I grab it. Okay, so that's one flash drive in. I am a model of organization right now. Do not follow my lead on that. There it is. Boy, oh boy. We'll get her. We'll get her. All right. You're like, man, why am I wasting time watching him dig around in his backpack for something? Okay. So let's get... Okay. So what I'd like to do is let's go in and separate this design. I just imported these vectors in, and let's move them off the screen for a moment. And I want to take those and add a new layer. You're going to see a little bit about adding layers here. Layer 5, and I want to make a copy of them. Or I want to move them, sorry, to layer 5. That way I can turn off layer 1, which is my design, and I can bring these vectors on. These vectors are going to help me explain to you you're going to help me explain to you how your start depth and cut depth works in your VCarve toolpath. So generally, what you will see in the tutorials and things online, when you see things about a V-carve toolpath, you will see that generally on the pocket cut, which is the female side of this cut, generally you'll see them set the female to about a 0.2, a depth of 0.2. In some of the earlier ones, you might even see a 0.3. You know, and for me, that's too deep of an inlay, but you know that depth of cut may vary. But on that female, you'd be starting at 0 at the top of your board, cutting down to a depth of 0.2. Okay, and whether you use a flat depth tool or any of that, that's really not necessary, because that cut, when that pocket and all, that's going to be glue space and everything, and so we don't necessarily need to change bits to create that flat area, you know, in the bottom of the cut and all, and everything. But when they create the mel, and let's go in, let's move this a little bit, move this around. I'm going to move this up here, and I'm going to grab my tulips here, my tulips. Stand by. Let's do this a different way. Turn that off. Select my tulips. There we go. And I'm going to make a copy of these to that layer 5. So I'm actually going to copy them over to that layer 5. That way I can turn this off and I can turn this on, and I've got this copy. Because what I would like to do with this is move that over here. With these guys, I want to size it down. Oh, Lainey, you're killing me today. Wonderful. All right, so those vectors, when I imported them in, they weren't grouped together, so it was causing a little bit of a selection problem. When I was selecting my tulips, it was selecting parts of that design. All right, so now let's say on my tulips here and everything, when I'm carving this, when I'm starting at 0, I'm cutting to that depth of 0.2, and I'm going to be using my 60-degree V-bit. You know, when I calculate this tool path, let's reset this back, and let me change this. I really wish this would stay. All right. So when I cut this or preview, you know, this inlay, then this is going to be the female pocket. This is going to be carving to that 0.2 depth, and it's going to be my female. And that's what's, you know, on my sign that we're going to be making, the love sign. This is what we're going to do. Well, now I've got to create a male version of this V cut. I've got to create a male version of this that is going to fit down into this female. And what these graphics are that I brought in are a way to show you how these cuts, you know, are created and how they affect themselves and stuff. So on my female cut here, and let's say, for instance, so we can be consistent, they're using a depth of cut of 0.3. Okay, so let's do that. Let's change this to 0.3. You know, on my depth of cut. All right, that way it will, you know, it doesn't matter. I use a depth of cut of 0.2, but we'll go with 0.3 just so we're all on the same page with one another. Okie dokie, okie dokie. So I've got this V-carve inlay that's cut down to a depth of 0.3. Okay. Now, So what that means is my V-bit here is coming through and it's cutting this V-carve cut and it's flattening it off at a depth of 0.3 in this case, okay? So if we notice the angle of that, the walls of this cut, the angle of the walls of this cut and everything, they are based on the angle of the V-bit that I'm going to be using, whether it's a 60 degree or a 90 degree or what have you. Well, now I've got to create my mel cut on this, but in order for me to create the mel version of this cut, there is one important thing that I have to do. I have to mirror this design. And I would be cutting this out of a contrasting piece of material, so I may have this up in the center of my board, whatever the case may be. I'm not going to move it for right now to simulate this, but I'm just going to make a copy. So I'm going to copy this to a new layer, and I'm going to call this layer my mel inlay. Okay. And I'm going to turn off all of my other layers except for that mel inlay. I'm going to leave that on. And on the mel inlay, I have to mirror it. So I want to mirror it horizontally. So I'm going to go into my mirror tool and I'm going to mirror it horizontally. I'm going to flip it horizontally. Now, be sure that when you are working and everything that you make sure the layer that you're working in is active, meaning it's highlighted and you should be able to see it up here. That's what happened right now when I just mirrored my design. You saw that stuff pop up. That's because I was still in that layer 5 when I mirrored it, and so it threw it over to that layer. So make sure I'm in my mel inlay layer now, and let's click my design and let's mirror that design and all. And I don't want to make a copy of it, so let's turn that copy off and let's do that again. There we go. So now I have a copy of this mel, and it's mirrored. Well, that mirroring it doesn't give me the mel version of this cut. Remember what I just explained to you about how a V-carve toolpath works. It cuts between the lines. So we've got to add another perimeter to this, and the easiest way is generally we're going to use, a rectangle of sorts. You can make it a circle, you can make it what have you, but rectangle is going to be a little bit easier, especially if you're cutting this out of the middle of a piece of wood, because you're going to have to cut away the edges and stuff so this inlay can fit in. And so Sylvia asked the question, would the pieces of flour come out like a puzzle piece? If you, because the way this flour is created, if I were cutting them out, all the way through type of deal, yeah, I could put it together like a puzzle in a sense, if that makes sense. But that's not what we're talking about right now, Sylvia. But yes, you could. They would cut right up. All right, so now I've got this rectangular boundary around this mirrored copy. So when I select this boundary here, I'm going to go and create a second V-carve toolpath. And on this V-carve toolpath, my start depth and my cut depth have to equal or total my flat depth of my female. So 0.3 is our magic number. We're trying to total that. And generally, what you will see is some people will have a start depth of 0.1. And in this case, if I had a start depth of 0.1, then my flat depth would need to be 0.2. You add those together for the total of 0.3. Okay, so I'm going to be starting down 0.1 and cutting from that 0.1 to a depth of 0.2, which is going to give me a total distance from the top of my board down to a total of 0.3. And this creates this wedge type inlay and everything. So if I were to calculate this toolpath based on that scenario and everything, then what I end up with if I reset this preview and all. And let's go back to our maple here, and I preview this visible toolpath. I'm going to end up with that kind of reversed cut of my female pocket. So I'm going to have this kind of raised area. Excuse me. All right. I'm going to have this raised area, and then of course from here I would have to cut out this design. So I'm going to have to cut out some kind of profile cut or something, or take it over to my bandsaw and cut the, cut around the edge and everything. Let's do that right now just to simulate this. And let's choose a end mill. And let's cut that out. Hold on a second. Let's give me a offset a little bit. Bear with me a second. Offset a negative point. We get a negative allowance in there, a 1/16 of an inch allowance to cut away that lip. Okay. All right, so now I've got this Mel version of that, and let me let it catch up to itself here. You zoom in. I've got this mirrored Mel version that's going, that when I take this carving and all, it's going to slip down into that female cut and everything. But I really want you guys and girls to notice something that's very important. First off, look at my cut here, and look at the top edge of that cut. You see these straight edges and everything here, and then it starts to go into that tapered angle and everything. That's because I'm using a 60-degree V-bit, not a 90. I'm using a 60. And on my 60-degree V-bit, my flute length is only 0.2. All right, and I'm trying to cut this to a 0.3, which means I'm actually going to be rubbing my shank up against that cut, and that's what's giving me this kind of flat edge. And this inlay is not going to fit together very well with the particular bit that I chose. Okay, so that's why, if I'm using my 60-degree V-bit, that's why my flat depth on my female is 0.2. Okay, that's why I don't go down to 0.3. If I was using a 90-degree V-bit, a wider angle, had a longer flute on it and everything, then going down to 0.3 wouldn't be a problem. I'd have a nice cut. But right now you see this straight edge, this ledge around the top part of my design and everything. That's not going to let my design fit together. It's not going to let it fit within its its pocket, its female pocket and stuff and all. So that we don't want and everything. So for me, what I'm going to do is, I'll let me change bits. Okay. So we'll come in here and let me go into the female cut, or we'll do the male while we're here. Let me go in here and let me change this to a 90-degree V-bit. We're going to talk about what those duplicates are in just a moment and everything. All right, and let me go back into my female cut. Change that as well. Got to use the same bit for both. Okay, so when I reset this preview and everything, if I preview, hopefully my 0.3 doesn't exceed the edge of my flute of my half-inch end mill, or V-bit, should I say, half-inch V-bit. Because if it does, I'm going to get that straight edge again and everything. So, but let's preview the toolpath, and let's see what our cut looks like. See if it's much improved. All right, let it finish flattening out and everything. It's a long preview. The V-bit's trying to, cut out all of this flat areas. And would you use a flat area clearance tool? I generally don't, because all that gets thrown away when it's all said and done after the two pieces and everything. So I don't bother changing bits, but you could if you didn't want to, take a long time with carving this and everything. Okay. So now looking at this cut, you can see that there's just a little bit of some of the areas here, just a little bit of flat, here where my shank is making contact. So, but for the most part, on the rest of the cut, I'm getting that nice pyramid V, cut and everything. So my inlay would be, set up. Now I don't go down to 0.3 inches period on any of my inlays. I just don't do it. 0.2 is about the maximum I go. If I want a little bit more meat or what have you in the inlay, I might go 0.25 or something, quarter of an inch. But now let's go back to our vectors and let's look how this male inlay is going to fit into the female inlay. First of all, we would take this male inlay cut over to our bandsaw in some form or fashion, and we would cut out the, around and cut out the edge and stuff so it could fit in. Getting rid of that outer rim, even that little V lip that's still left there. By this cut, I don't have enough of an offset allowance in there, but even that little V, we couldn't have it. You would take your bandsaw or whatever and you'd cut this design out so it fits together like a sandwich. Okay, now let's go over back to our vectors and let's close this, turn this off for a minute, and let's come back in here and let's look at what's happening. Okay, so let's focus on up here at the top. Okay, so my V-bit, when I have my start depth at 0.1 of an inch with a flat depth at 0.2, okay, this line here represents the flat depth that it's cutting to, and this line here represents the start depth that I'm cutting to. The outside edge based on the angle of the V-bit, okay, the outside edge based on the angle of the V-bit is what, it's going to be cutting this male part. So if I were to take this shape that you see here, it might be a little confusing seeing all of these lines and everything, but at that 0.1, my bit is going to, the actual edge of my bit is going to be offset by this distance here. So when you're doing a when you're using a V-bit, if I were to take this V-bit and everything, and let's say that this line right here represents my vector, this line I'm running against, well, the cut based on my cut depth, I'm starting at 0.1, so already my bit is being offset and brought down. This is where I'm starting at, and you know, so it's going to be, you know, offsetting to that point. Now, when it cuts down to its final depth, you know, which is going to be that total distance of 0.3, I'm going to be offset in a way that it creates this angle based on the angle of my bit. And the outer edge of the bit is where it's going to cut to. And so if I were to trim away, if I were to come in here and trim away parts of my design, let me see if it'll let me do this. Oops. Wrong line there, Laney boy. Okay. And so now I've got this piece here that's my mel. And now if I take that mel over to that, oops, let me turn off. If I take that mel part, which would be this part here that you see on the bottom, this part here, okay, and I take and slide it into that female, which is this part here, okay, that angle and that depth of cut and everything, this is 0.3 way up here and all. So when those two parts go to fit together, that inlay, they're only going to go so far, okay? And this air gap here, this void, is going to be where you would have glue space or what have you, but it's going to be a big void. And we don't, you know, that's not what our goal is, because our inlay is only going to be, you know, in that area where that contact, as far as the two parts can fit together. Okay, so when you see these tutorials on YouTube and stuff, I'm getting to that, David. When you see these tutorials and everything, and you see, you know, like a cut depth of 0.3 and a start depth of 0.1 and a flat depth of 0.2 and everything, you're going to end up with, you know, an inlay that it will fit together and all that wonderful stuff, but you're going to have air gaps. You're going to have voids. It's going to be very, it's not going to be, you know, very strong in a sense and everything. And if I had to do another inlay inside this inlay, I'd end up running into this pocket of air. And I'd end up with voids and gaps and stuff like that, and, you know, not very good. So what are the alternatives? Well, create a higher on the mel cut, create a higher start depth and a smaller flat depth. You know, in this case, I could create a start depth of 0.28 and then a flat depth of 0.02, just 20 thousandths of an inch. And what that's going to do for me is that's going to give me this, you know, inlay from here, you know, and my bit is only going to be offset, you know, so much and everything that if I were to take my trim tools here and let's create this inlay. Okay, so now I end up with a piece here where my bit was only offset a slight amount because of that high start depth and low flat depth, and that 0.28 plus 0.02 totals my female cut of 0.3, right? You know, totals my cut of 0.3. and everything. And so now when I go to fit this part together, let me grab the part that's hiding over here. When I go to fit this part together now, oh, stop for a second. Let me get my female there and everything. Now, because of that high start depth and low flat depth and everything, now when my two parts fit together, they're going to fit together much more appropriately, leaving me still a nice little gap for glue space and everything, and not create such a big void as what we had before. Let me turn off that male inlay there. Is what we had before with the the higher start depth and things. So, this is what our ultimate goal is to get a nice filling inlay into that part. And they're like, at what point in time was this a basics course? Well, you have to understand V-carve inlay. Once you do one, they're all pretty much the same. Rinse and repeat. The only thing that changes your design, but you need to understand how it works, how a V-carve inlay works in order to understand the process. So for me, on the flat depth here, on the start depth here, we would change the start depth. In this case, as the example shows, is a 0.8 start depth with a 0.02 flat depth. When we calculate that tool path and everything, reset that preview. Okay. Now our bit is going to, when we preview that visible toolpath, now we're making that bit plunge down into the maximum depth of the cut and everything. And then, with the small area to fit in. And let it finish carving. Now notice on my bit, see this big old, all right, let's stop there. There ain't no sense in wasting time with this. All right, notice on my bit, my flute isn't long enough. So I'm getting all this straight edge meat right here. Can't have it. Can't have it at all. That's my shank. That's my shank of my that's the straight edge in the shank, and all, unless it's a 1/2 inch head. But that's that straight part of the V-bit. It's not the angle anymore. It's the straight part of the V-bit and everything. And so we're not getting the cut that we require. So I'd have to use a much bigger bit, longer and all that stuff. Let's go back to my cut depths, and we'll use my depths. Now that you know from the diagrams and stuff and all, I'm going to now calculate it with my depths that I use. So on my female, my flat depth and everything for my female cut and everything, my flat depth is 0.2. Okay, I'm using a 60-degree V-bit. My flat depth is 0.2. That is the goal that I'm going to with this. And sometimes it may even be a 0.15, but generally 0.2 is my kind of go-to depth. All right, so that's my female. We'll calculate that and kind of get that out of the way. That's my female cut. On the male cut, my cut depth and my start depth and my flat depth have to equal that 0.2. And so I would have a 0.18 start depth and a 0.02 flat depth, okay, for a total of 0.2 inches. And I use a 60-degree V-bit. Let's change back to the bit that I use. I use a 60-degree V-bit. I got to go back and change the female as well. So let me calculate this. So 0.18 start depth, 0.02 flat depth. All right, so let me go back into my female cut change this bit. Got to use the same bit for both the male and the female cut. Okay, so now if we look at this male properly, let's reset this preview and preview the visible toolpath. Let it carve out. Almost there. I should have turned the simulation quality down a little bit, but I want you to be able to see this not so pixelated and everything. Yeah, Todd. I mean, that's a good way that you could put it. Is it seems that the inlay is depth of the flute, depth dependent, and it is. You know, it's going to be. It is going to be that and everything. You know, because if you're hitting your shank, you're burning up your wood, your inlay, because you get that straight edge. That shank is the shank's not cutting, right? The flute is, so that's why you have that straight edge, you know, and all that stuff and everything, you know. And so now I have let this finish up. Okay, so and let me do the profile cut here. I'm going to make this cut over a little bit more. -0.1. Let me cut out the part. So I take this over to my bandsaw, and you know, I cut out the part and everything. And this is, let's click on this. Okay, and so now I'd have my male inlay that I'm going to take over to my female, put a little glue on both. I glue both. Some people only glue one or the other. I put a nice little layer of glue on both pieces, both parts and everything, you know, because I don't want to dry joint and stuff. And I don't want to oversaturate. I don't want to puddle in the female pocket. I use a glue brush and everything. But so now I'm going to, you know, on my inlay and everything, I'm going to have a nice solid inlay with very little glue space. So that when those two parts come together, you know, I'm going to have a nice inlay that's got some meat in it, you know, in a sense, and very little space for glue. You know, I got to have some glue space and stuff. And then that's going to leave me a nice little gap between the female and the male that I can take my bandsaw blade, or I can take a hacksaw, or you know, a saw of some sort, and I can cut the two pieces apart and then sand the male flush to finish off my inlay piece. Okay, so when you're watching those tutorials and stuff, and you see, you know, like some, you might see a cut depth of 0.2 and a start for the female, and a start depth of 0.1 and a flat depth of 0.1 and everything. There's nothing wrong with that and all that, but that's just going to leave you that wide air gap. You know, you're going to have a little bit of a wide air gap and stuff. A higher start depth with a smaller flat depth, and you do want to give it some flat depth. Don't be going to a 0 flat depth type of thing, you know, or whatever, you know what I mean. You want to give it some flat depth and all, but you're going to end up with, you know, a little bit more solid inlay, a little less glue space and gaps and things like that, air gaps and stuff and all, and so it'll come out, you know, a little better, you know. So keep that in mind. In my numbers, once again, my flat depth, I use a 60-degree V-bit with mine. There's no right or wrong or what bit to use, what bit not to use. I use the 60 because it's my go-to bit. My start depth on my female cut is 0 with a flat depth of 0.2. Okay. For my male cut, the male inlay, I have a start depth of 0.18 with a flat depth of 0.02. Okay, again, I'm using a 60-degree V-bit. Now that number may vary depending on your bit and all that stuff as well and everything. But generally, I want a little bit of meat. I want a little bit of an inlay. I don't want it to be too thin of an inlay and stuff. So, you know, I'm going to be at 0.2 or, you know, above when I'm using my 60-degree V-bit because of my flute, as Todd put it and everything, with a flute and all, then you know, that limits my cut to a 0.2. Now Todd says, why do you use a start depth? Why not just use a flat depth of 0.2? You can't do that. Okay, Todd, you have to have a flat depth of a small amount. It's all based, and we're going to go through this one more time. It's all based on your vectors. And let me see if I can turn this back on, and let me draw this back in that I just trimmed away. Okay. If I have a zero start depth, and let me get this. Bear with me a second. I got to make my V-bit. Cut the vector. If I have a zero start depth, then on that start depth, my vector's over here. The line of my vector is, you know, over here and everything. So if I have a zero start, oops, I'm clicking on the wrong thing. If I have a zero start depth, there's no offset. There's no offset and everything and all. I need that offset. And by creating the start depth, it's offsetting my bit, that distance and that distance I need for that angle, for that fit and everything. And it's bringing it down to, you know, that start depth. And it's cutting from that start depth to my final flat depth, in this case to that 0.3. So let me get my bit over into position. Oh, come on now. Snap over there. To give me that bit of an offset and everything, I have to have a start depth. Have to have it, or else I'm not starting in the correct place. I've got that have that bit offset over and down to where it needs to start. All right. Yes, Todd, it is. It's an offset thing. Okay. But you don't put it in, you know, there's no allowances and blah, 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 this. That's your start depth. Okay. Hopefully you understand that. Okay. All right, so let's get these layers and everything turned off. Get everything turned off here and go back to my design. Okay. Now, let's go ahead and turn that off for one more second. Don't need this here. Delete this. Delete this. All right. So on my design, I need to take my original sized flower, right? I need to right click and make a copy of this to a new layer, and I'm going to copy it to the mel inlay layer. And on that mel inlay, I'm going to be cutting that mel inlay out of a completely different board or something, so I'll most likely move it into a position where I can cut it out and all that stuff. But on that mel inlay, okay, I'm going to position this, you know, somewhere on my material because I'm starting from the bottom left corner, and I'm most likely going to be using a smaller piece of material. So on that mel inlay, I would go ahead and create my boundary around it. Oh, you son of a gun. Always make sure your layers are active when you're drawing in them. I have a bad habit of that. All right, so I'm going to draw my boundary, and then I'm going to take my Mel inlay and mirror it. I'm going to flip it horizontally. There we go. All right, so now this would be set up for me and ready for me to create my Mel V-carve toolpath, which is this guy right here, you know. So I would go ahead and while I'm here, I'd calculate that. We're going to talk about these duplicate vectors that keep popping up. You'll see what those are in a moment. And so that would be my Mel toolpath that I'm cutting out of a contrasting piece of material. Now on my actual design, turn this off. Okay, on my design, my female, I would select this here and my female inlay. Let's make sure nothing else is selected. Okay, making sure nothing else is selected. I'm going to be starting at 0, cutting down to 0.2 with my 60-degree V-bit. That's going to be my female cut. Okay. All right, so that's going to be the 2 tool paths for the inlay part of this sign. Okay, I'm going to rename these. So this is my female V-carve inlay, and it's going to be a 60 DEG V-bit. And number 3 here is my Mel V-carve inlay, and that's also a 60 DEG V-bit. And I'm most likely on my cut, because I'm going to be carving that, I moved that Mel over to the bottom left corner because I'm going to be carving it out of my X and Y is going to be the same, because I reference off of my jig. So I just throw that 3/4 inch piece of Mel, walnut, whatever it is, and it would get cut out over there. All right, so I've got my Mel and my female inlay. Those are done. Now on the actual text and everything, the actual design, the text and all, this would be the regular V-carve toolpath. No flat depth on this. I'm going to let it just V-carve out to its normal depth using my same 60-degree V-bit. This would be my text V-carve. And again, it's the 60 DEG V-bit. Calculate that out. Okay. So what I'd ultimately end up with is if you use your imagination and I preview these 2 visible toolpaths. All right, let's give the female inlay a little bit of color so it will kind of simulate it. We'll give it let's go to more colors. And let's go to this dark custom here and kind of darken it up a bit. And then on my text, let's give that a color of, I don't know, sky blue or something. Who knows? And so I would have, my cut here, and then I'd have that inlay over there that would be filled in. It wouldn't be carved out looking like it. It would be filled in with another piece of wood. Contrasting color, I'd most likely use a walnut and all that. So Rusty asked the question, he says, instead of cutting the Mel inlay, have you had any luck using epoxy filler? I don't use epoxy fillers. I haven't, to date, Rusty, in what I've done. Now I use epoxy for like my river tables and things like that. But as far as inlay filler, using it as an inlay filler and all that stuff, I haven't done. Now, we have for the woodworking shows and everything, we have used an epoxy filler for creating like a nice little U.S. flag on a guitar and things like that, and it does really well and everything. You just have to, try to get rid of your air bubbles and stuff. And if I were using an epoxy, I would be using like an eco-epoxy and stuff. I would use like an eco-epoxy and all. Maybe I would put, a little bit of their powder granules in there for that marbled effect and stuff and all. But when I do an inlay, I do an inlay. I don't use epoxy fillers and stuff, but I have used epoxies, and I use a eco epoxy, ECO epoxy, eco epoxy, Now, so we have our very basic design here, and on the text and everything, I paint it or do whatever, or as Rusty was saying, is epoxy fill. The only thing you got to keep mindful of is you're going to have to sand and polish that epoxy. So remember how thin your lines are here. The last thing you want to do is you've got a very small amount of epoxy going around this rim, if that's what you were going to do, and there's not a whole lot of meat there. I mean, you're only you're only 30 thousandths of an inch, 0.03. So there's not even enough for a fill on this outer edge. On the inner edge, you're much deeper and stuff. So keep that in mind and everything. But now, a very basic V-carve design with a V-carve inlay. I hope some of you do take a chance and create some inlay, but let's take a look real quick at this design. We did simple text, wrote out our text, and using a different font to kind of give it a little bit of a different style. We distorted one of the lines to give it a little bit of an effect, like the words are growing just like the flower. We're giving it kind of that effect and everything there. With the flower itself, doing a bit of an inlay for a decorative aspect of it. I could have just V-carved this and painted it. I don't have the inlay, but I wanted to, show you about the V-carve inlay and kind of explain that process and all. Now, when we are creating the text, and let me come in here to I'm going to add a new layer so I can turn this off, so I can go to blank screen. When we were creating the text, I mentioned the first thing that I said is we have two different ways of creating text. Our draw text tool, which is what I use to create the text, but we also have the draw text within a vector box. Now, the draw text within a vector box, what this does for us is if there's a certain area that I need to lay out text in, then I can set a bounding box perimeter for that text. And by default, when I open this up and I have nothing selected here, my bounding box is the actual board, right? You see this dotted line going around the actual board here? Well, if I came in and changed that dimension, let's say that I use let's go with a 6-inch wide by 2-inch tall bounding box. Now my text is going to be fitted to this bounding box, to these perimeters of this box. So, and use the example of the word love, since we're kind of working with that. Now, as I create the word love, it's going to be created inside of this bounding box. And whether I'm a left justified on this, or if I'm center justified or right justified, when I create the box, it's going to be based on my margins that are around my box and everything. So I have margins that it's going to be created on. So left, center, and right justified right now doesn't show anything because I have margins. Okay, I've got normal margins set. Now if I had no margins set, then it's going to it's going to align the text. It's going to stretch it out to fit that box. Now, if I said, okay, I want wide margins, then it's going to create wide margins around that text. And the text alignment really doesn't work with this. It's it's just going to justify it based on my bounding box dimensions, my margin size, and then of course how I stretch my text. Now, if I say I want no margins, it's going to stretch the text up automatically till I'm reaching the outer edge. But now only my horizontal stretch is reaching the outer edge. If I need my vertical stretch as well, then I'm going to come into the vertical stretch and I'm going to stretch the characters. Okay? I'm going to stretch the characters to get that to reach that vertical limit also. Now, if I had normal margins and I stretched my characters and everything, it's going to stretch them out. So if I had none, right, that's my normal look right there with just normal margins, no stretching. But if I stretch my characters, it's going to stretch them, and I can stretch them vertically and horizontally. And it's going to fill that box area to the best it can based on my parameters that I set here, my parameters. If I had no margins, it's going to stretch it out completely. If I had normal margins, if I had wide margins, so on and so forth. And I can, if I had lines, if I had multiple lines, I can space the lines to fit within this boundary area that I'm limiting. If I, my spacing on my horizontal, my letter spacing and things, I could, stretch the spacing of the characters and everything if there was an application for that and everything. Or I could just stretch the characters themselves. So when I'm doing an auto layout on the text, basically when I'm using this tool to draw the text within a vector box, it's basically creating a virtual vector box that I can position anywhere on my board, or I can already have even a regular vector drawn out and selected and all. But based on those box parameters, that text is going to be restricted to that box size, and it's going to be stretched and everything according to my margins, normal margins, wide margins, no margins. Do I want to stretch my characters horizontally and vertically, so it fits and everything. And then of course if my bounding box dimensions change for whatever reason, then let's come in here and go 8 and 2, and my dadgummit, keep clicking off that text there. My letters and all are going to be adjusted accordingly and things. So when we're drawing text, we're kind of free forming and we're basing the text on, and let's get off of the word love. When we're drawing text in our regular tool, we're basing it on a text height, a text height and a font, and it's going to, go out accordingly. If we're drawing text within a vector box, then it's being controlled by the dimensions of that box. Okay, so it's going to be controlled by the dimensions of that box, whatever the case may be. So just keep that in mind. I wanted to show you those two ways of drawing text. Lainey, what does the wood text look like without color? Oh, sorry. If we turn off the colors, it's just, and I can make it look like, piece of pine. Let's see here. Let's go with, like if I was making this out of a piece of pine or, a piece of cherry, So without color, if that's what you're asking, Sylvia, what does the text look like without color? Let's go back to maple. You know, that's what it looks like without color. All right. All right, so we have just, let's go back to here and turn on our layer 1. So now we've just created a very basic sign with some bee carving, and we also created a very simple inlay. And inlays, you know, your design for your inlay could be, you know, a variety of things. I had a trout. It makes a really cool inlay. Little trout fish jumping out of some water and stuff. And I was going to use that for tonight's class and stuff. But the tulips, that's another one of my inlay vectors and all. And by the way, food for thought here. When you trace an image, and I said this the last time, and I'm really going to reiterate this. You should only have to trace an image one time. Okay? Once you've traced an image and you've converted it into a vector, export that vector, select that design, you know, that traced image and all, and export it out of your software as a DXF and save it in a DXF folder somewhere on your computer. That way, if you need to use it again, you can import that DXF file and you don't have to trace the image again. Okay? You should only ever have to trace your image one time. So keep that in mind. Now, I want to talk to you about duplicate vectors and open vectors and stuff like that. Now, if you notice, all through the process of creating these toolpaths, you've probably noticed that at some point in time there was a message box that would pop up that looks something like this, that says ignoring duplicate vectors. And it's telling me that there are 29 duplicate vectors that were identified in my design that I've got selected here. And it's ignoring them, and there's 29 remaining. You know, of course there's 29 remaining because it's duplicates, right? So what it's basically doing is it's creating the toolpath and ignoring those duplicate vectors. But why do I have duplicate vectors to begin with, and how can we identify duplicate vectors? Well, I knew right away that I had duplicate vectors by the first time that I selected one of these vectors of the flower. Notice in the visual, if you can see here, that I have a pink line, but there's a black line underneath it. It's almost like a pink dotted line, and between the dotted lines is a black line and everything. That black line is visually tells me, and your eyes will start getting trained to it, that there's another vector underneath that one. You know? So if I were to select that vector and that duplicate, and I were to delete it, and I were to come back and select my vector, I should have a nice white background behind my vector. I should have a nice pink and white dotted line and no other duplicate behind it. I should not see any black behind it. You know, that tells me that I have a, you know, that I don't have any duplicate in that area. Now, so I have 29 duplicates, meaning all of these have duplicates. And why do I have duplicates to begin with? Where did they come from? When I was tracing the image, when I was tracing the bitmap image, I traced it accidentally twice. I clicked the button twice, and it traced it twice, and it drew it twice. And when I clicked that preview, I clicked it twice, and I applied it twice, and you know, before I closed the tool out, and it ultimately created a duplicate vector. It created the duplicates for me. Now, how can I check for duplicates? Well, I can right-click on my screen and go down to Selection and select all duplicate vectors. So as it selects all duplicate vectors, you can see here how I have their pink, but you see the black behind them. You see the little black behind them. That means that there's another vector behind those, or on top of them, or what have you. Now, notice that when I right click and select all duplicate vectors, notice that the you've got to let it grow got selected as well. And so if we look at you've got to let it grow, we don't see a black dotted line. We don't see a duplicate vector in there. And so there is no duplicate vector in here. it just for some reason got selected during that selection choice. I'm not sure if it's because of the distortion that caused it to get selected as a duplicate or what, but it was selected. So we're going to turn that off, and with the rest of these duplicates selected, I'm just simply going to either hit the delete key on my keyboard or right click and choose delete to get rid of them. Because I should now, if I go to my selection, select all duplicate vectors, I should not have any duplicate vectors in my design. Okay, no duplicates in the design. So we should be good to go and everything. So if you're ever selecting and you see a black dotted line, kind of pink with black behind it, that means there's another vector behind that. It's a duplicate, that got created somehow or another. It got created twice, or what have you. In my case, when I traced my image, I applied the tracing twice, and so it created the duplicate. And that's why I had that duplicate. So you want to clear those out, or else you're going to get those messages. You're going to when you're calculating a toolpath, you're going to get those messages that, hey, you've got duplicates, or you've got open vectors, or you've got this or got that. You got to clean those up and stuff. Now, an open vector, if I were to take this tulip leaf right here, and if I were to go into node editing mode and just pick one of these nodes and just cut the vector right there. Now, looking at that, can't even tell that there's an open vector in there. But if I went to create my vCarve toolpath on this, if I were to go into my vCarve toolpath on this and I calculate, it's going to tell me that, hey, you have one open vector, and it's being ignored. So it's going to carve the other 28 vectors. So if I were to calculate this toolpath, then my whole design, and let's reset this back to a blank board, my whole design, my whole flowers are going to get carved except for my feather. That one leaf that's supposed to be right here, it's going to be ignored and everything. So if you see that warning, a open vector that's being ignored may be insignificant, might not have any effect on your design at all, or it may be very significant. In this case, it's very significant because I'm missing that whole leaf right here. I'm missing that whole leaf in this area here. So I would want to definitely come back and identify, right click and selection, select all open vectors. I would want to identify that open vector, so have it select. Now, some vectors, bear with me a second. That little guy that I just drew right there is microscopic. If we come and zoom out here, other than a little speck right there, that could look like a piece of dust on my screen or what have you. If I were, let's say that I were V-carving this whole design, and I select all of my vectors and stuff and all, and I come in here and select all my design, and I come in here and create a vCarve toolpath, and I'm not going to set a flat depth, no flat depth, just a vCarve toolpath. I'm going to calculate this. It says, hey, you've got two open vectors, they're identified in the selection, they're going to be ignored. Well, okay, do I hit cancel and kind of go find them, or do I just click OK? Well, what I do is I test it. I click OK. I look at the design. If I don't have any letters missing or nothing significant is missing and stuff, then I let it ignore it, But I eventually go back and I try to find that open vector and figure out what it is. If it's important, close it up. If it's not, get rid of it, type of thing. And so in my case, if I hit cancel, meaning that I didn't create this toolpath, I'd come back over here and I'd right click and go to selection and select all open vectors. Now, I see this vector here, okay? if my eyes aren't trained well enough that to notice that there's another little blip on the screen down here, and some of them are even smaller than that. That there's a little blip right there, a little black dot. If I zoom in more and more, you can see it, type of thing. But when I'm zoomed out full screen and stuff, if my eyes aren't trained and I'm only seeing one vector, I'm like, okay, well, let's close it up. So if I come over here to my Join Open Vectors tool, I would see that, okay, I have 2 open vectors selected. Where's that other 2, and everything. And then I come back and it's like, okay, after joining, I'm going to have 1 closed vector and then I'll have 1 open vector. And, so I'm like, okay, well, I'll at least close one of them. So I'll click on join and I'll close that. And, I go back and I think, okay, that took care of it, right? And I go back and select my entire design and I go to hit calculate and I'm still getting that 1 open vector. Where in the world is it at? I don't even see it, type of thing. Well, if I right click on the screen and I tell the software to select all open vectors, right? I just said, hey, software, do me a favor, select all the open vectors. Right? Well, now I can use my magnifying glass. My magnifying glass, the third one with the pink dotted line around here, which is zoom active view to the selected objects. Right? I just told the software to select that open vector. I can't see that open vector with my eyes, I don't know where it's at. So heck, if I zoom into the selected, it's going to zoom right in to that selected vector. Now I can go, shoot, where was that thing at? And I zoom out a little bit, and now that my eyes are concentrated and focused on it, going, oh man, that's just a little speck. That doesn't even need to be there. Well, I have a choice. Now I can right click and delete it, or hit the delete key on my keyboard, just get rid of it. Right? It's insignificant. It's a little speck. It's a little pixel or what have you that was selected and everything. And so now I zoom back out. But that little trick, right click, select all open vectors, and then, shoot, I still can't see any pink. Where did it select it? Well, hey, let's zoom into that selected object. Use the zoom tool to zoom into that selected object. That way it brings it to our forefront, so we can deal with it and everything. So it's a nice little trick you might not thought of, but there you go. Now I can right click and select all open vectors, and I should have no open vectors in my design. And therefore, I'm good to calculate my toolpath without any error messages, except for one error message saying, hey, you're going to cut through your material if you try to V-carve this. Well, I don't want to do that, so I'm going to set a flat depth. I'm going to limit the depth of cut, and we'll calculate it. Okay. So we'll reset that and preview that toolpath, and there we go. So, easy and quick ways to identify duplicates is by actually looking at the line. You should, when you select an object in vector, it's a pink dotted line or it's a pink solid line. If it's a pink solid line type of deal, the Vectric software will not show you duplicate vectors within a group. It will not show you open vectors within a group. What I mean by within a group, let's say that I have, a circle here, and another circle here, another circle here, and let's say that open vector, or that vector, we're going to go into node editing, we're going to cut it. We're going to cut it right there. Now that I've cut it, it's an open vector. All right, if I select this, and I group these together, right? So now the software looks at them as one object and stuff and everything. Well, if I go to select this and I go to create my, let's say, a V-carve toolpath, right? I'm just using V-carve as the sample right now, but I'm using a V-carve toolpath and everything, and I calculate this. The software is going to say 1 open vectors were identified and they're being ignored. Some or all of these open vectors are in a group. Grouping vectors together does not join them. Just because you group them together, it doesn't join them. It doesn't close that vector. It's saying you need to ungroup that group and fix the open vector. Okay, so it's telling you what you need to do. So joining them doesn't it doesn't close it off. You have to physically join or close with your join or close tool. Grouping it doesn't do anything. So if I came in here and I right click and I select all open vectors, well, guess what? Look what it says. No open vectors in the design. It will not show me open vectors that are within a group. Okay? So the software, the toolpath just said, hey, knucklehead, some of the vectors that are open are within a group. You've got to ungroup them, okay? So when I'm like, well, dadgummit, I'm just told it to select all open vectors. It's saying there's no open vectors design. Now I'm having a conflict with myself going, man, the software just says right now, it says there's no open vectors in the design. But my toolpath is saying that there's open vectors. What in the heck is going on? Why I can't figure it out type of thing. And you start pulling your hair out type of deal. Well, it will not show you open vectors within a group. That's what it is. So if I were to take this design and ungroup it, and now I come in and right click and select all open vectors, it's going to select that open vector. It's going to show it to me. But it didn't show it to me a moment ago because it was within a group. And so by grouping these together, it didn't close it, so I have to physically come over to my join tools, one of my join tools, and I just use the regular join tool, and it would show me that I have one open vector, and after I click the join button, I'll have one closed. And, now I'm good to go. Now, if I want to, I can regroup these guys back together if that's what my intention is, or I can just, calculate my toolpath, whatever the case may be, and so on and so forth. So if you're getting messages that, hey, this vector is being ignored, and you're like, where is it at? Where's this open vector at? Because when I'm trying to find it, it's not showing me, and when I tell the software to select it, it's not selecting it, and all this stuff. And so where the heck is it? Well, make sure, look at your design. If you have anything that's grouped, just take a moment, ungroup it, and then check for open vectors and stuff. Because the toolpath will tell you. The toolpath will say, hey, some of these vectors are within the group. You have to ungroup them to fix that and everything. Okay? So just keep that in mind. And with me, I had duplicate vectors. Okay? I had duplicate vectors. And if I were to make a Control C, Control V, a copy and a paste, I just created a duplicate vector on this pedal right here. So there's a duplicate vector. If I came in and grouped that together, right, still got a duplicate in there. If I came in and created my toolpath and I calculate this, it's showing me that I got one duplicate vector. Right now I got that duplicate vector, and it's gonna just carve the other 29 and stuff. Well, if again everything is grouped, so if I came in here and I right click and I select all duplicate vectors, just like the open vectors, it's going to say there's no duplicates in your design, buddy row. There's nothing there. Well, it's not going to show me the duplicate vectors that are within a group. So what I need to do is I need to ungroup this object, and then I need to, have it select that, duplicate vector for me so that I can go in and handle it appropriately. Let's turn that off, and I'll go in and right click and delete that duplicate and get rid of it. So now I should have no duplicates in my design and everything. And then I could go back and select my flower and regroup it back together and all that stuff. But so open vectors and duplicate vectors, if you run into that issue where you're getting these messages saying, hey, it's there, it's being ignored and all, and you're like, well, where's my letter E at? Where's my letter O? Where's this and where's that? Because the vector's open or whatever the case may be. You got to go through and you got to clean them up. And just and grouping them together doesn't do it. That's the whole point of this. Grouping them together doesn't fix the problem. It just hides it from you and makes it more difficult to find and stuff. Okay. All right, ladies and gentlemen, we're going to open the floor up for some Q&A. Hopefully, No, we're not. Not yet. We gotta. I promised a young lady that I would do a keyhole toolpath and show you about that, how to use the gadget and how to do it without the gadget. So let's do that real quick. I'm gonna flip to the other side of my board. Okay, I'm working on the bottom side of my board now. I'm gonna create my keyhole toolpath. Now, if you have Vectric VCarve desktop, you don't have access to the gadget library. So that's why I'm going to show you how to create a keyhole toolpath without using the gadget, because you don't have access to that gadget library. You know, for VCarve Pro and Aspire, you guys have access to the gadget library. And within that gadget library, we have a keyhole toolpath gadget. Now, notice that when I went and selected that keyhole gadget and to turn it on, it says, hey, please select one or more circular vectors, okay? Because the center of these vectors is going to indicate the entry point of the keyhole slot, all right? What that means is I have to draw a circle where I want my entry point to be. Now, notice because I'm flipping my board, on the Y side, right? Notice that all my vectors on the other side are upside down looking. This is the top of my board down here. So if I were doing a keyhole slot, you know, the center of my board is here and everything. So I'll probably come off center a little bit and, you know, I'm going to draw my circle there. Now my circle, it doesn't matter what the diameter of the circle is because we're going to be setting those parameters. We're going to be setting those parameters within the keyhole gadget. So I have a 0.3 diameter circle. So we're going to click apply. Okay. Or not apply. We've got this circle here now. So now I'm going to go in with this circle selected first. Now I'm going to go into my gadgets and I'm going to go into the keyhole toolpath. Now with the keyhole toolpath, let's see if it'll show you this window because it's supposed to be showing everything within the Vectric VCarve window. So stand by a second and let me make sure that it shows this window to you before I get into a long explanation and everything. And you're going to hear a pause for a minute because there is a delay between what I'm saying and what you're actually seeing on the screen. So stand by a minute. Let me see if it opens the stand by. Okay, just what I thought. So what I need to do is I need to switch windows real quick. Bear with me a second while I switch to my web shot scene. There we go. All right, and now you should be able to see that window as I switch to the web shot scene. Oh, sorry, I had to take a sip of something to drink. All right, now within the keyhole gadget, I have options. First of all, the slot's orientation. Do I want it to be a vertical slot where it means it's going to start from the bottom where my circle is and cut upward, you know, towards the top? Am I going from the top to the bottom? Am I going horizontally left to right or horizontally right to left? And in my case, I'm going horizontally right to left. From the right side of this over to the left side, over across the center line of my board, basically. Okay? And if I would have drew the circle on the other side of that center line, then I probably would have went left to right, right? Doesn't matter. So we're going right to left on this. And now my slot dimensions. And so it says the depth of the slot. Well, the depth of the slot is going to be dependent on the keyhole bit itself. So let's cancel this for a second and let me draw out a keyhole router bit. Look at those artistic skills. My goodness gracious. All right, so let's go up here and let's select these together and let's weld them together. All right, so this is going to be my keyhole bit. Let's move that over to the side here. All right. And let's go back into that gadget. Let's select my circle and go back into that gadget. All right. So now the depth of my slot. Now the depth of the slot is going to be very dependent on the head of that keyhole bit. You know, how wide that keyhole bit. We need that bit to plunge down and it to at least clear that head, right, to get up into the neck area. Now, most of those heads, depending on, you know, I have a little keyhole bit from Lowe's, and the head itself is roughly, you know, from the bottom to the top of that head is roughly about, you know, 3/16 of an inch. You know, it's not very big and everything. So the depth of my slot is, you know, 1/4 of an inch. You know, that's how deep that I'm, you know, cutting down to and everything. So that I know it's going to clear my head and everything to there. Now the length of the slot, how long I want the slot when it cuts, how long I want it to be is, you know, I generally do a 1-inch slot, you know, and of course, you know, that would be whatever length you want it to be. Now, the parameters, you know, to create the preview of my keyhole bit, you know, on the surface and everything, to create the preview vectors and all, it's asking me what my entry hole diameter is going to be. Now, the entry hole of my keyhole bit is actually 3/8 of an inch wide, 0.375. Okay. The slot diameter, the neck that creates the slot of the keyhole bit on mine is 3/16 of an inch, you know, 0.1875 in diameter. It's 3/16 of an inch in diameter and everything. And, you know, the layer, the tool path that's going to be created in the layer and everything, what do I want? You know, it's going to create a layer for this in my layers tab. What do I want that name to be? You know, so in this case, I just let it default to keyhole preview. Now, this is one area that people get the most confused about is the setting the bit. They're like, okay, how do I draw the keyhole bit into the tool database? You can't. You don't. Keyhole bits and dovetail bits and things like that, you don't draw and you don't put them in as a form tool in your tool database. You use what's called a dummy end mill, a fake end mill that's going to represent your keyhole bit. Now, all the toolpath is doing is it's using the feed rate and the plunge rate and the RPMs, the feeds and speeds. That's all it's using of this dummy bit. So my keyhole bit, when I select the tool and everything, generally my keyhole bit is the same feeds and speeds as my 1/8 inch end mill, you know, and everything. Now, I don't have a spindle. I have a router, so my spindle speed in here is incorrect. I'd be running around 22,500 on this. But, you know, but my feeds and speeds are correct. So, you know, the 1/8 inch end mill I'm using is kind of my dummy bit. Now, you can actually just create a dummy bit, you know, a keyhole bit, you know, using an end mill and name it keyhole bit, you know, whatever you want to call it and stuff. Because all it's doing is when you select that tool, it's using the feeds and speeds only. Okay, it's just controlling the bit using the feeds and speeds, because it's going to come and it's going to plunge that bit down to 1/4 of an inch. It's going to then come over 1 inch, come back 1 inch, and then it's going to come back out of that same entry hole. So your depth of your slot, at least deeper than the head of your bit. 0.3 is a good depth on a 3/4 inch board type of thing. 0.3. I'm using 1/4 of an inch here in this example. 1 inch slot is a decent little keyhole slot. Entry hole, 3/8 of an inch. That's the head, the diameter of my head here. My neck diameter is 0.1875. So when I click calculate or create, it's going to create this guy right here. A little vector preview of my keyhole slot. Okay. Now, notice my keyhole slot's going in the wrong direction. That's because, and I'm going to delete this. That's because, I'm going to delete this vector too. When I opened that gadget that second time, I forgot to change it down to my horizontal right to left. All right, let's click OK. There we go. That's more better. So that little, it's creating a little outline showing me where my keyhole bit is, but it's also showing me my tool path, the tool path here. Okay, that tool path is going to come down into the center of this circle area here. It's going to go up 1 inch and it's going to come back and it's going to come out of that hole. All right, so that's how we would create a tool path, keyhole toolpath using the keyhole gadget. All right, now, Laney, I don't have Pro or Aspire. All I have is desktop. How would I create a keyhole toolpath to accomplish the same goal? Well, very simply, we would still kind of draw our circle out here, you know, just to kind of, for us, we're not going to utilize it in the calculation of the toolpath and all. We're going to, I'm going to leave this vector here. I'm just going to turn that layer off for a minute. All right. So this is where I want my, you know, I'm going to use this circle just to kind of help me lay out where I want to start from, right? Now, what we're going to do is we need a bit, we need our keyhole bit to come down at the center of this hole, go to a certain distance in whatever direction we're about to draw our vector, turn around and come back out this hole. If I just draw a straight line, I'm going to snap a line from here to, let's go 1 inch out. Oop, overshot it. Okay. All right. Oops. Let me turn that keyhole preview off. Oh, you son of a gun. Bear with me. Okay. If I just draw a straight line, thinking that that's going to do it for me, well, let me create this toolpath. It's going to be a profile toolpath, right? Cutting to a depth of 0.25, right? That's what I want. I'm using my 1/8 inch end mill, my dummy bit, okay? And I'm cutting on that line. And if I calculate this, let's take a close, hard look at this toolpath. Let's tilt this to the side and zoom in really tight here. Okay. All right. So, first of all, that profile toolpath has been created with 2 pass depths. So we got to go back in there. We don't want to do it in 2 passes. We only want it in 1 pass, you know, but my 1/8 inch bit is set up to take 1/8 of an inch per pass, you know, blah, 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 or, you know, a 1/16 of an inch, what have you. So I need to go in here and I need to edit my passes, all right? I need this to be 1 pass, all right? Take that full 1/4 inch plunge. So let's recalculate that, okay? So now what's going to happen is, notice my 2 green lines here. The green lines are showing me where that router is going to raise up. That router is going to travel all the way over from my home position. It's going to come down. It's going to plunge down to that 1/4 of an inch. It's going to cut, and then it's going to raise up and pop another hole on the other side. No, we don't want that. Okay? We need that bit to literally come down, cut over that 1 inch, come back, and back out of that same hole. So the trick to this is, what we do is, on our line here, is we're literally going to create a 1/1000th of an inch step over and bring that 1 inch line back. Okay? So what I normally do, the best way to draw this for me, is I use a rectangle. I create a rectangle. that has a width of 1 inch. You guessed it. But it has a height of 0.001, 1,000th of an inch. Okay, we're going to click OK. And let's take that rectangle there. Now let me put this on to, let me move this over to my layer to turn off that keyhole toolpath. All right, so now if we zoom in really good on this rectangle here, this is a very small rectangle, 1,000th of an inch. All right, well, first thing I want to do, this is my entry point, this is my exit point, you know, these two areas here. I'm going to grab the center of this rectangle. And I'm going to, you know, grab the center of that rectangle and I'm going to move it over and snap it to the center of my circle. Yeah. Okay. So I'm going to grab the center of my rectangle and I'm going to snap that. Let me find the center of my circle here. Boom. Snap it right there. All right. Now I'm going to come in here and I'm going to zoom really tight in here because I can't have a rectangle. I need a path. Okay. So I got to go into node editing mode and we're going to delete this line right here. We're going to delete this line. Okay. So basically the bit's going to come down. It's going to travel. Let's get this on full screen here. It's going to come down. It's going to travel that 1 inch down. It's going to come over, step over just that 1,000th of an inch, and it's going to come back, and then it's going to raise out of that hole. So let's go ahead and let's create, let's select our vector here, and let's calculate that toolpath. Okay. And now if we zoom in, okay, we can see we have one path here. It's going to come over, it's going to come down, it's going to come across, step over that small 1,000th of an inch, you know, and come back and then raise up out of that entry hole that it created, you know. And so that's how we would create. And so your line, your path, that down, over, and back path can be whatever length you want it to be, whatever direction your keyhole is going to go. You know, in my case, I'm going from right to left, you know, over the center of my board, but you might be going another direction, whatever. But like I said, when I'm drawing, I use a rectangle. It's easy for me to draw my however long I need my keyhole slot to be. And then that 0.001 is the height. Okay, and then when after you create that rectangle and get it positioned where you want it to start, you know, and all that stuff, come in here at the end and remove that end line, you know, to create that path. Okay. So that's how you would create the keyhole slot. That's how you create your keyhole slot with your keyhole bit without using the keyhole gadget that you don't have access to if you have desktop. So that bit's going to come down into the hole. It's going to come down and cut that 1 inch. It's going to step over ever so slightly. That 1,000th of an inch is going to come back and come right back out of that same hole and everything. And that 1,000th of an inch is so small you won't even notice it in the step over and everything. Gotcha. Good. All right, so that is the two ways of creating a keyhole slot with the gadget and without. Hopefully you find that helpful. Tippy Looter says, why did you lay the keyhole out horizontal instead of vertical? Is there a purpose? Yeah, Tippy. I'm going to be hanging this on the wall. And when I hang it on the wall, I want, let's imagine that this is the top of my board up here. When I'm hanging it on the wall, I want to slide it over the screw head and then slide it left or right so it balances on there, you know, and hangs on there. If I had that vertical, you know, now if well, let's do it the other way. If I had it vertical, now I've got to get that thing, got to be dead center, or else it's not, it's going to pivot. It's going to pivot. It's not going to tilt. It's going to be leaning down one way or another. If I'm not quite centered, my picture will be hanging crooked and all that stuff and all, you know, I don't want to fight with it and everything. I do my keyhole slots horizontally. So that way, you know, it's spanning over my center line and everything, but they have room for adjustment. They can adjust it left or right as they need to on the keyhole slot to get it to balance perfectly on that screw neck or screw head. Okay. Now, Cecil Morrison has a very good point. And Cecil, generally, you're referring to a T-slot bit, not a keyhole bit. And in my experience, Cecil, and I'm not saying that you might be right. I'd have to look, you know, but T-slot bits generally do not have a cutting neck, and you have to use an end mill to remove waste material. But keyhole bits that are specifically designed to make keyholes do have a cutter on the neck. T-slot bits that looks 100% like a keyhole bit for making T-slots don't have, you know, typically do not have a cutter on the neck. So you have to use an end mill to clear out that waste material and stuff. But keyhole bits generally do have a cutter on the neck. But Cecil Morrison is correct either way. If your bit, let's say you are using a T-slot bit, and you don't have that neck that will cut it, it is very necessary to use a straight bit for a clearance cut to cut out that neck, to cut out that slot and everything, you know. But generally, and Cecil, you know, we can do some research together on that. But generally, a T-slot bit will not have a cutter on the neck, and it's used for making keyholes or T-slots like T-track T-slots and things like that and stuff like that. But a keyhole bit that is specifically designed for making keyholes will have the cutter on the neck. But if you know, I may not be 100% correct. You know, there could be some, you know, off-brand bit out there that I'm unaware of that doesn't have. They call it a keyhole bit, but it doesn't have a cutter on the neck. I would refer that as to a T-slot bit. But either way, if your bit, what Cecil's trying to say here, what he's trying to bring to everybody's attention here is, if your bit has the little T-slot cutter head, but it doesn't have a cutter on the neck, don't try to run a keyhole slot without doing an end mill, a straight bit pass to cut that slot first. Okay? So basically you would be using that bit to widen out the gap. So what you would do in that case is down here, you would have two tool paths. One, you would have a clearance tool pass. You'd have a center line. So let's go all the way down here and let me draw a center line. Bear with me. Stand by. Draw a center line here, and let's make that line 1 inch. And spacebar to finish. And let's go into node editing and change my start point on that center line, or else it'd be a bad day. Let's go in here. Go into node editing and make this the start point. Very important, because I want it to start here where I want my keyhole slot to be. So I would have a third line here. This third line would be used first to create a profile toolpath on the what am I trying to say? Would create a profile toolpath And let's create a tool profile toolpath. Cutting to that same 1/4 of an inch depth, using a very small end mill. Your end mill needs to be at least the diameter of the neck. Okay, very important, of the neck. So if my keyhole slot bit, T-slot bit, I'm not going to call it a keyhole, but if my T-slot bit didn't have a cutter on the neck, which it doesn't, then I would have to use a bit that has the same diameter of that neck. So I'd be using my 0.1875 bit, you know. Most likely, it would probably, my T-slot bit might have a smaller neck, whatever the case may be. But anyway, I would use it. I got to create a path for that neck to get into, right? So I'd calculate this tool path. And what this is going to do is, it's going to go down and it's going to come up, which is not a problem. I don't mind it coming up because that's not my keyhole slot. My keyhole slot is going to be made with the fat round head of my slot bit. So it's going to go down, it's going to carve over, and it's going to come up, and it's going to go home. Then I'm going to change, and I'm going to put my T-slot bit in, and I'm going to cut my T-slot and everything that is going to go down, come up, come all that, and that fat head is going to create that undercut of the wood that creates that creates that keyhole slot, that T-slot type of thing. So if I am using a T-slot bit as a keyhole bit, then I have to have that extra tool path in there to clear the way for the neck of my T-slot bit. But I highly recommend using a keyhole bit that has a cutter on the neck to avoid that. But you might be making T-tracks for your wasteboard on your table, right? And you're using a T-slot bit. That's what I use my T-slot bit for, is for my T-tracks on my wasteboards and stuff like that. This is exactly how that would be created. There'd be a center line that I'd use an end mill to clear out the waste area. Then I would throw in my T-slot bit, and it would run that path. Back on. Because, unless my T-slot was running the whole length of my wasteboard, then, of course, it's going to run and it's going to come out the other end. It's going to come up and out the other end. But if I was using it as a keyhole bit, I got to have it go down, over, and back. All right. No, Tippy, I wouldn't. Tippy Looter says, if the diameter of if the bit diameter is the same diameter as the neck, wouldn't I want to follow the same path as the T-slot bit? No, I would not, because what's happening here is this slot width right here is, my bit is my neck and everything. I'm wanting to carve the center of the slot. So my T-slot bit is coming down, over, and it's coming back. My head or my slot needs to be centered on there. If I follow this path, then the center of my 3/16 inch bit is cutting on here and everything. And I mean, you can try to follow the path. I don't. Let me draw a circle here. 0.1875 diameter. Click apply. Oop. Okay. 0.1875 diameter. All right, let's turn on the, let's get this keyhole bit back where it belongs. Let's rotate that 1, 2, 3, 4, and let's get it centered back down here so we can see. I mean, I guess, yeah. I guess if you're using a keyhole bit that the neck, the end mill is the same diameter. Let me see here. Let me get my keyhole slot centered. Bear with me a second. So if you're using I wouldn't do it. If you're using a keyhole slot and your bit diameter is the same depth and all, you can follow the same path as the outer perimeter tippy. But if you're using a T-slot bit, I wouldn't do that. But either way, we'll delete that line. We'll use the same path. And I don't know, somebody give it a try. If you screw up your keyhole, blame it on Tippy. Yeah. See, my biggest concern with that, Tippy, I don't like that because I'm stepping over 10 thousandths of an inch. So when I'm using, if I was doing it on a straight line, Buddy Row, then that would be one thing. But I've got two lines here separated by 1/1000th of an inch. So when I go down and cut, the edge of my bit is cutting on that neck, right? But when I come here on that same diameter as my neck, right? When I come here over to that back path and everything, you know, I'm overshooting it and all. I would use the center line. To be honest with you, I would use the center line to clear that path. I wouldn't follow the path. It may be fine. It may be fine, you know, but I wouldn't follow it. I wouldn't do it. I'd use the center line. You know what I mean? So I wouldn't do it. I would use the center line because you know, I'm stepping over. I don't want my, you know, my diameter of my bit's going to be on one side of the line, then it's coming over 10 thousandths to the other side of the line, and so it's going to be overshot on this side. If I was following the center of the bit down the center of a single line, that would be different. Okay, and that's what, by using the center line on here, that's what we're doing. We got our 3/16 inch bit running that center line, that center path. I would use the center line. I wouldn't follow the path with it. Nope. I wouldn't. But again, guys, one way to avoid all this is get a keyhole bit. Get a keyhole bit that actually has a cutter on the neck, not a T-slot bit. If you're going to do T-tracks and T-slots, then you've got to deal with this. Okay? If you're doing keyholes, get a keyhole bit. Use an appropriate bit for the job. And that'll eliminate all of the confusion. Okie dokie. Okie dokie. All right, ladies and gentlemen, any other questions that you have? Now is the time to ask them. Otherwise, it's 10 o'clock and we are going to close for the evening. So hopefully learning how to do a keyhole slot with or without the gadget. Remember, our magic number is for our step over of that is that 10 thousandths or 1/1000th of an inch, 0.001. That's our magic number, you know, for that step over and everything. You know, so that's what gets that bit, that profile to go over, cut down, come over, and come back out of the same hole that it started in. That way it don't blow out the other end of your keyhole type of deal and all that stuff. So you just, you know, if you have any questions, that would be the way to go. Now, as far as the center line thing goes, if your T-slot bit doesn't have a neck, you have to clear out that path for the neck. Otherwise, it's going to be a bad day. You're going to break a bit. You're going to damage wood. You're going to be pushing wood around. You've got to clear out with an end mill like Cecil had brought to everyone's attention and stuff. You've got to do that. You've got to run that straight, that path and clear out that path and everything. Now, Tippy brought up the point of, do we follow the same path as the keyhole bit or that? Now, I use a center line. I wouldn't follow the path. Never have, never will. But Tippy comes back and says, is the T-slot following on the line or off the line? I am seeing the bit dropping 1/1000ths. By the way, I have a keyhole bit. So the center of the bit is following the line, Tippy. The center of the bit is following the line path and everything. No. So the center of the bit is following the line. Now, either way, guys, give it a try. If you want to try following the path with an end mill type of thing, if it doesn't affect your keyhole slot, then go for it, right? You don't have to draw your straight center line. I don't do it that way, but I'm not an authority on it, right? I use a keyhole gadget 90% of the time, but I'm not the authority on keyholes. Give it a test. Test it both ways. See which way works best for you. Alrighty. And let's see here. Can you get the gadget for desktop? No, Todd. Desktop software does not have access to the gadget. Desktop software does not have access to gadgets. Any of the gadget library, desktop software does not have access to it. Okay. All right, ladies and gentlemen, y'all have a wonderful night. You've been a wonderful audience. I greatly appreciate all of your time and everything. Thanks for hanging out with me. Hopefully there was a little something in this project to give you a little bit of something to play with. Maybe you'll go out and create an inlay, right? A V-carve inlay for the first time or something. Or maybe now you'll know how to create a keyhole toolpath so you can hang your signs up and stuff without having to put actual hardware on the back or anything and hangers and all that stuff. Give it a try. And by the way, this marketing script font that I used for the word love, that is available on dafont.com for download. Dafont, DAFONT.com for download. All right, ladies and gentlemen, until next time, see you soon. I want to thank you for joining us tonight on Spindle TV, your best source for CNC CAD/CAM training videos. If you're watching Spindle TV on YouTube, be sure to hit that thumbs up button and subscribe. You can find out more information about our training and products by visiting us at www.digitalwoodcarver.com.